Welcome to Let's Roger That. I'm Gilles. Well, I'm gonna do some more surgery to the surface grinder. That's not looking healthy at all, right? So here's the issue. This is for cranking the, what I call the Y-axis in and out. And so this bronze or whatever, bushing is toast. So gotta make another one. So off to the lathe and let's make one of these things. Should be really interesting and quite a lot of complexities to this whole mechanism. And of course, yeah, this is the retaining screw. Should be fun. Let's go. It's worth taking your time when you're looking at having to fabricate something that is this complex. Look at the bearing grooves that would have to be done and all this stuff. I mean, it's easier to clean this stuff up than to make it from scratch. And look at this. So I not only, it would be quite time consuming to make this, but I would have to manufacture a lot of tools. But one of the things I could do is drill this out and just make a bushing to replace the broken part. That should be a whole lot easier, as long as I, I can always oversize the hole, that's not a problem. So just a matter of calculating what bit I have, what size hole I can make, and then make a bushing from that point on. I've measured this hole and it is 723 thousandths of an inch. So that's pretty close. Let's look at the chart here. And I know I have all the bits for this. So this would be 10 thousandths of an inch. Making a bushing that thick would be a real problem. But one that would be about 27,000 shouldn't be too difficult to make. So let's have a look at what 27,000 looks like. Good enough. Okay, so it's pretty thin, right? But that's the difference. You're gonna split that by 2. So that's way too thin. Way too thin. All right, so we'll need to pick something a little bit bigger. Say 7/8 of an inch. I wonder what that inner ring size is. Let's measure that. This kind of hand's a real problem. So that is 866, 7/8 is 875. So that works for me. Just drill this out 7/8 of an inch and go from there. Now, what's the damage going to be on this side? It should be okay. It shouldn't come into where the bearings roll. So that's what I'm gonna do. First thing I gotta do is take this apart, because obviously the part fits on this. You should have seen the bearings explode out of there. It was quite interesting. So, oh jeepers, that's tight. I'll lift that out of there, because we'll need that to take some measurements. So this is where the dial was sitting on earlier. This little set screw here allows this to be locked onto the lead screw. This comes loose, for whatever reason. So that is another issue that I need to resolve as well. May actually have to remove the lead screw from the surface grinder. Now here at the lead screw, that part I was showing you earlier, eventually, it sits in here. So that And so it sits against a washer, a thrust bearing, another washer, the lead screw nut. Now this used to come loose all the time, go further in, cause all kinds of problems. And I believe that's how this part became damaged. And so I put Loctite on this screw here, or not. So it's fixed there permanent, which is just fine by me, because this is a brand new lead screw. And so once I tighten this up against it and reassemble that, it should be fine. That little set screw I was showing you goes in here. So I may, this should be fine, but we'll see. I may yet have to do some surgery on that. I'll tack a welding and re-drill it so it sits in there only in one spot. So clearly this has been damaged in the past. That's that.Moving on. All right, let's start by drilling this hole. See if I can snake my way around all this stuff. It's kind of a crazy setup. All right, here we go. Have a quick look, see what's going on. Aha! So somebody had inserted a bushing in there at one time. Look at that. Okay, or two. Now let's keep going. There's more to be done. Like I must be through. Let's have a good look. I can't tell. Lovely. All right, we need some more. Let's keep on going. This is bronze. I shouldn't need oil while I'm doing it anyway. Definitely through now. All right, let's take it out and see what's going on. Withdraw the tailstock. And let's have a look at this here. Nice clean cut, look at that. I'm happy with that. Okay, so now it's time to make a bushing. So I'm thinking I'll probably just make a mild steel bushing or brass or something. Yeah, brass doesn't sound bad. Because whatever goes in there, I'm going to glue it in. Okay, so let's measure the diameter. It's 177 thousandths. Okay. So that's only 2 thousandths over 7/8, which is really great. Okay, so here's what comes next. This diameter that I just bore is 877 thousandths. The shaft that has to go in is 712 thousandths. So we're going to go with a 710. No, the other way around actually. That'll be 714. Need room for it to move, right? So 114. The length is 1.812, and how I calculated that is I took a measurement from here. Let me see if you see that here. From here all the way to the bottom. And I added about, let me see here. I took the measurement of the bearing, which is 195 thousandths. And then I subtracted 50 thousandths because I want the face of this to sit on the bearings. This here. I believe that was the cause of the issue before, that this the lip that held the bearings in kept shearing off, because there shouldn't be pressure on the lip. That's just a retainer for the bearings. So that's what I'm going to do. Time to take this and make a bushing out of it. There's some 1-inch brass. So that's what I'm going to use. Look at that. I got a little stamp a while back. A little paw print. Isn't that cute? Love those kind of things. First thing I'm going to do here is face this part and center drill it. Not going to drill right through yet because I've got to bring down the diameter, and inevitably the tool bit pushes on this. Brass is pretty soft, so I don't want to bend the part right away. Like if I were to drill everything out, there's a risk that it's going to really mess it up. So that's how I've decided to do it. You could do it many different ways, but that's what I've decided to do. So, brass, you got to turn pretty fast. So this is soft brass, 1 inch. We'll go say 500 RPM approximately. Should go faster, but this will do the trick for me. Here we go. And I'm just going to manually face this. I'm not going to get all crazy because everything gets drilled out of this thing. Okay. All right. We'll bring the center drill, put a little hole in that thing, and then later I've got to drill it to 11/16, which is the closest diameter that I have for drill bits to get to 712 thousandths. The rest I'll have to bore, which is fine. Good. Yeah. Now that's done, I can move on to turning this down. So now I'm going to move my tool, my cutting tool. So this is 1 inch. We'll bring this down to, what this here, 877 thousandths. So probably worthwhile taking a bit of a measurement right now. Yeah, so we're exactly 1 inch, so that's great. 123 thousandths to go. Voila, it's as easy as that. Okay, let's test this out. We need to see if the bushing will fit inside this piece here. And that's still a little too snug. let's see if that fits. Yep. Nice. Not too tight. It'll do just fine for gluing. Okay. Now, need to bore this thing. So, let's set up for that. Okay, I'm going to bore to 2 inches right until I reach a diameter of 11/16. So here we go. Okay, so now I'm boring to 11/16. I'm boring to 11/16. And then after that we'll use a boring bar to do the rest. That's it. Now let's set up to do some boring. So I'm now boring, and as you can see, I'm going backwards. Where's my camera? Going that way, right? And that way I don't have to worry about crashing into it. I can go all the way into the cavity and do the boring and still get a very nice finish. That's why I do it. Finished boring the part, so let's see if it fits nicely or not. Yay, that works. Perfect. Okay, great. Turns freely, that's all I wanted. I guess I'll cut this off and move on. Alright, so I scribed an idiot mark. I'm going to tell you how. Of course I did it with my calipers, just like everybody else does. And you know what? If it wears down, I'll buy another pair, so don't worry about it. Okay, so I'm going to cut this off, and let's do that. Oh, by the way, the length had to be 1.812. I don't want it any longer than that, because otherwise it causes problems, right? Remember the bearing measurement thing? Right, there we go. Just to see if my brain fart worked, what I did is I inserted the shim in here, the bushing, and I've put all of the bearings, which in theory should have extended past the bushing. So now I'll put this in here just to test it out. Yeah, I love it when a plan comes together. Okay, so that's great. So now from now on, this piece should not be destroying that separator bushing. All right. The other part that needs to be done is a touch of welding on that shaft. So perhaps what I'll do is I'll remove all these bearings, acetone clean everything, glue it, let it dry, and do the welding. That's what I'll do. So now that I have this machined and glued in, I've put the bearings in. I've widened this little slot to make, or to let this set screw go through correctly. So we'll do this so we don't lose any bearings. And then put this on here, the flat spot's created. And it's snug, so I have to work at it. Okay, I've reassembled this thing here. Trust me, seeing bearings flying all over the room wasn't all that much fun. So now all I got to do is put this back in here. There you go. And screw this back in if it's lined up correctly, which I don't believe it is. So to do that, there's a little hole here. You move this touch, and voila. I think it's threaded in correctly. Yes. Or no. Yes. Okay. Once that's in, there we go. Now, is this gonna work out correctly? We'll find out soon enough. There we go. There was too much pressure on this thing. What you're seeing here is the new shaft, which holds the turn wheel. And the reason I made this new one, it was simply because the previous one was not concentric. And so as a result, it would make the handle difficult to turn. I wasn't getting a consistent travel across the surface grinder, and that's not conducive to getting a good surface finish. So I simply decided to remake this. It wasn't no big deal. It just took an hour, and now I've got something that turns really well. So let's continue the installation. This is the dial, which is in 1/1000 of an inch. I made a new 3/16 key. Put this on. That's as simple as it gets. I like simple. Okay. Let me show you. Look how smoothly this turns now. There's no, difficulty in turning and whatnot. So I'm very happy with this repair. Well worth my time. So thanks for watching. Please like and subscribe. Love to read your comments, and I reply to all of them. So take care, folks. Bye-bye.